what kind of impact are you seeing? If you do this right, is the efficiency of the production going up by 1%?
80%
How much?
faster, 80% faster tool loading.
80%?
Yes, 80% faster tool loading processes in the shop floor for the operator.
Dr. Marcel. Marcel, can I can I call you doctor?
If you want to, for me it's fine.
But you are a doctor because you actually have a PhD
Yes.
in what is it? PhD in what subject?
Mechanical engineering.
But related to data.
Yes, so especially I made a typical PhD in mechanical engineering. My topic was process planning by using also data-related optimization methods. Call it also AI, so supervised learning, and so that's why I'm having somehow a little bit of profession in digital manufacturing. Yes.
So you're one of those folks that studied the subject that you're now applying as in your profession. You actually stayed and committed to your career.
Yes, yes. I really like to now have this transfer from the research world into the real manufacturing world. And to do it directly in regards to a machine tool builder, because that's a kind of data source, which is really helpful.
And machine building is such a specialized topic. How did you pick machine building as what you want to do?
So in the past, when I was younger, I started to work in some kind of jobs to earn a little bit money during the school time.
Yeah.
And I started to work on shop floors, in factories. And especially there I have seen what can be optimized. And me as a person, I really like to optimize things. And then I see process flows there. I see with what kind of things the people are struggling. And I thought the whole time it can be made better.
So before you become a researcher, you actually saw the real work on a factory floor, on a shop floor.
Yes, different companies, yes.
And then were you a part of the assembly? Were you working on those machines? What were you doing there?
Part of the assembly, typically, or doing just stupid things, like
when you were a student,
packaging one thing to another. So simple work to earn money in between my school time. But I really like to get to know these worlds, to step into a factory and to see what's happening there and how is the outcome. And what are
I always find those two worlds very different because factory is so physical. Like you actually touch things, you assemble physical objects.
Yes.
But when you go to school and you study, everything is data, models, concepts.
Yes.
And so connecting those two is not easy.
No. Because, how to say it, the real world, of course, uncertainty is a topic there. So everything can happen. Like when human people are working together, that's one aspect. But another is, of course, that the machines can have problems. There can be failures. Something is not coming into the right time, for example. What should we do now? How could we fix problems? And I really liked it. So as a mechanical engineer, I think I'm a typical problem solver. I really like to solve problems, but I really like to optimize things.
So do you still stay? Do you still touch things in your current job?
Yes.
Or are you now, yes?
Yes. So of course I'm working on digital solutions and on the digital platform and on data related optimizations. But for what? For the machines, for the people who are working in the shop floor, because they are the center, and to assist them better with this data-related solutions.
And the things that are changing now with data is AI. AI is coming in and interpreting the data in a new way. Are you seeing this already move from your office, from a research side, into the production side? Is AI touching the actual real work today?
Yes, I think it's coming more and more, but I think that is also what I've seen in the research world. Data is the key, And of course, also in the research world, we had very good examples, of cool things which we have tested in the lab. But the problem is that are special cases, We worked on that for a paper, for example. But in the real world, we have to find solutions which are robust, which will work for the customers. And that's why I would say, first of all, data should be really good recorded, should be measured in a good way, should be afterwards, how to say it, filtered, selected, and then of course AI solutions can come and help. That's one thing. Of course, another thing will be to assist people working in the factories. And thereby we have the opportunity to also use data-based solutions with some kind of uncertainty, but the people in the end have to make the decisions. Yeah.
So let's unpack it, because these are two concepts, just two unique concepts. One is taking the theoretical data or practical data, but data, and then making it relevant to the physical, physics-oriented world where things have to happen. So tell me more about this before we shift to making people actually work with it.
Okay, got it. So I think, and when we are staying in this physics-based world, it's really important that you're having a look to your use cases. There are a lot of use cases which can be solved with physics-based models, so their data is not needed. But then we have also other cases,
Why is data not needed when you talk about physics-based model? Wouldn't data be part of how the physics models are constructed?
Of course, yes, can be the case, but in mechanical engineering, mathematics, physics, every time important, You don't have to build up a huge AI model to solve some things,
Because you actually have equations to calculate things, yes.
Got it. And we have to see the difference, The difference between such cases and cases in which AI is really helpful and needed, because somehow it can be calculated by a quotation. We need another solution.
Are you solving same problems that you're solving with physics now with AI, or are you solving things that you couldn't solve with equations? Is that the second option?
More the second option, I would say, because otherwise it makes no sense to build up such huge AI-based models with uncertainty. Because for the customers, it's very important to have robust, good solutions, which, how to say it, will help in every kind of situation. That's also really important.
That flexibility of AI, because it stretches beyond what the model can predict.
And the manufacturing world, it's really complex. So the customers are using different machine types. They are producing different kind of work pieces with it out of different materials and so on.
But we're still being very theoretical. Like, give me an example. What does it mean? Give me maybe a use case you're working on.
So when we are working on the machines, you have to set up some process parameters. The machines must be programmed somehow. So somehow understand it as parameters for the machines. And at the moment, there are experts programming the machines with a lot of knowledge. But in the future, we don't have so much people with so much experiences, with so much knowledge. So the question is, how can these kind of parameters can be set up to the machines?
I see. So the model is there. The set of parameters is set already because you have a machine running. But now you're optimizing those parameters based on a new set of models. That's the AI bit.
Yes, for example. And then, of course, we have different somehow influences. So think about the material, for example. It's titanium, aluminium, or even another kind of material. Then we have the so-called tools, which are somehow manufacturing a part of the material, and the tools,
like drills, CNC machines,
for example, milling tools, drilling tools, or even grinding reels or something like that. So different tools which we are using, and there are a lot of different combinations. And at the moment, we have really, really experienced experts who are saying, okay, when you're combining this milling tool with that material, then you need this kind of process parameters. But in the future, we need also solutions to optimize such processes. And of course, the machine tool itself, it's really important because it sends out directly the feedback. What is happening on the machine? Which kind of forces are acting at the moment?
Because not all the parameters are set. Temperature changes, like other variables. The material may not be exactly the same.
A lot of different things are happening there. And of course, you can think about different sensors. There is also a lot of data already on the machine, because the machine runs with controls, for example. These control types, they are having also at the moment data, but we need to find solutions to make this data useful. How you filter this data, how you bring it into a model, yeah, and how this model can be then directly helpful for customers.
Okay, so you're solving a very complex problem, but now you also brought people to it, because we still have people on a factory floor, on a shop floor, they're operating those machines.
Yes.
And I stopped you with describing of what it means for those
Yes,
operators to
that's the
actually
second
work
thing.
with it.
Yeah.
Yeah, what does it mean?
So I think the human people are in the center of the shop floor. And in the end, of course, they are so important because they have to make decisions also in that complex situations. Yeah. And I think AI models can help to assist these people finding the right decision in the end. And it's like every person know it at the moment. They are using Copilot, ChatGPT, all the different models which are out there, these large language models.
So operators are already asking questions of the models today when they operate those machines?
So you can imagine such solutions, but not directly with this large language models which are for everyone there. So you can think about, for example, about large language models which are using only manuals, for example, from the machine, or some kind of documents about process parameters, for example. And then this kind of things can help to find very quick solutions in the shop floor when decisions must be done. Yeah? Mm-hmm. What kind of process parameter is now in that situation the right one? Yeah, then the people can be assisted.
So is it easier for an operator to work in an environment when they now want to ask AI for advice, ask questions, relate to content through AI, or is it more difficult for them?
I think
they need to learn new skills?
No, I think it's easier because they know it already from their typical normal day, using Copilot, for example. Yeah? So somehow the people are getting more and more in contact with such things to solve problems. Yeah, and but that's the second thing as we describe it now. Yeah. The first thing is more using AI-based models to directly find a solution. Yeah, it's the people are not directly in contact with that kind of models. Yeah, but this way, which we have now described, is more working together with AI-based models.
And both things are happening at the same time.
Both things are happening, of course. You have to think about this kind of different versions of AI models: supervised learning, unsupervised learning, and so on. Yeah, and reinforcement learning. They are so much more than large language models, and it's important.
And DMG Mori, your company,
yes,
the largest tool machine builder in the world, probably one of the most sophisticated one, or the most sophisticated one. Mm-hmm. Are you using all these methods in your daily work? How far did you push the envelope on what's possible with AI?
I think for us as a machine tool builder, it's really important first to build up a connectivity in the shop floor. That's really important, the base. Machines have to be connected. Data must flow around
But that's such an old problem, connectivity. I remember that conversation from 10 years ago.
Yeah, but in the shop floor and manufacturing world, of course, it's again really important because not every machine is connected. But because this kind of complexity, it sounds so easy to do it, yeah? Connect every machine and so on. But we have really different machines, yeah? You have our machines are drilling machines, milling machines, turning machines. And at the moment we are even combining these processes in one machine. So we have really good machines which are combining such processes. Yeah. But think about the real shop floor, then you have also other machines. Yeah? And also these kind of machines have to find a way to be connected to each other. Yeah? And only then...
So how are you solving for it? What's your new way to think about it?
So first of all, we have connectivity solutions to also make, first of all, our new machines directly having this connectivity, of course.
And this is machine data collected, pushed into one lake?
For example, we are having our own cloud system, for example. That's one opportunity, but there are also open standards like OPC UA. It's also very useful when you are using different machines, machine types. That are possibilities. And on the other side, you must think about that machine tools are for a very long time in a shop floor, 15 years. And now think
Those
about
are
the
not
problem.
new machines, yes.
Yes,
Those are
and-
machines that's been there before the IoT even got started, yes?
And that's why we have also retrofit solutions to bring in connectivity in older machines. And we have also the solution with our IoT connector Flex to bring in connectivity to machine tools from other machine tool vendors, so from other machine tool builders. It's also possible because we think that the shop floor has to be connected. That's really important.
Is it still the same type of data that you're collecting from the machines, or as the time progresses, are you able to derive new data points or new?
I think, it's a developing issue.
Yeah.
Because more and more ideas were born to use other kind of data types. And so for example, we have sensors, hardware-based sensors, but you can also use, for example, soft sensors. Yeah. So use another kind of data type to predict one thing. Yeah. And that's, I think, a really interesting idea, also coming from research. Yeah. And to bring that into the reality. Yeah. Use data, but predict other things with that data. So don't directly measure the force, for example, which is acting on a workpiece.
Yeah.
Measure the how to say it, the power from the machine, for example, and thereby make some calculations to come to the force.
And is it more effective? Is it easier? Is it giving you
Easier to implement because such force sensors, for example, are expensive or complicated to implement in the machine, and thereby,
or difficult to retrofit if it's an old machine?
of course, difficult to retrofit also. Very good example, yeah. And thereby it's there can be really cool ideas and solutions by using the things which we are already having in the machines. But think about from another perspective, how this data can be used.
So you have more data now. You are bringing data from the existing infrastructure. New machines are already connected, way more sophisticated. It's still data. You still don't have an answer to, interesting questions. How do you get to answers? How do you get to, higher yields or less problems on the floor?
Yeah, I think it's important that the data must get into context. Yeah. So, in what kind of situation a good quality was resulting, for example, on the workpiece itself. Yeah, and that's why you have to think about end-to-end solutions regarding the digitalization.
And what's end-to-end? Like, tell me, what does it mean end-to-end?
It starts when there's a person in the office and the person programs the machine. And there already data is used. For example,
But when they program the machine, they already have a concept of what they want to make? Like, are you going all the way back to like design and engineering, or are you within the production environment?
I think the best way will be also to go back to the design, but that's more a thing for the future. Let's start now. Design is already there. We are starting with.
So now you know what part you want to make.
Yes,
Okay.
we start with the programming, yeah. But there are also very important questions. Which kind of tools must be used to how to produce that workpiece? Which kind of tools are on the machine in the shop floor? Which kind of tools are available? And there's already a connection, for example, yeah, from the machine to the office, yeah. And then somehow the question is how the workpiece will be clamped in the machine, how it will be fixed in the machine. It's also a connection from the machine to the office there. And then we will go from this programming, yeah, from the office to the next step into the.
You call it programming. Is it programming or modeling?
Not programming. We call it
Yes.
in the manufacturing world. It's
Okay.
computer-aided manufacturing. It's programming. CAM software will be used, and it's more that, like we call it. Yes. And then please think about the machine and the manufacturing process itself. Of course, there data will be generated. Like I've said it before. How much power will be needed to bring the machine into rotation, into movements? Yeah, this can be used, of course. This kind of data. Do we have alarms, for example, during the manufacturing? Is something happening there? Can be used.
But give me a picture. Like, what are we making? What's a good example of something that goes through this process? Is that a piece of machinery? Is that a drill? Is that a huge part of a car, or like, I want to imagine what it is that we are making here.
Yeah. So You can imagine, for example, a part from automotive industry, but also a part from aircraft industry. So different things out of metal materials like aluminium, titanium, they must be manufactured. And we are starting with a block, for example, and in the end,
block of aluminum, a block of titanium.
Yes,
and then you have to manufacture that part out of it.
Yes, Subtract processes will then take, part per part material away from that block, and in the end, we have a really complex thing, the workpiece. But you have to think about the machine will move this kind of milling tool, and then the machine will have to move also the workpiece in different axes, and in the end, really complex surfaces are the result of it. And when I've started to talk about the whole, process itself, we started at the programming phase, but then we have the machine tool itself, the producing of it. In the end, also quality. What kind of quality is resulting? And how this can be integrated into this data loop. It's also a really interesting thing. There can be optimizations done in the future. And when we are building such a feedback loop of data, the data can be put in more into a context. So which kind of process parameters are resulting in a good quality? Which kind of tools which we are using are resulting in a good
And you can also measure now impact of whatever you're doing. So what kind of impact are you seeing? What level of improvement are you going after when you drive these processes?
So like I've described it before, so the impact of process parameters, for example. But another kind of way how you have to think about that issue is, for example, the efficiency of the operator. So the impact can be also that the operator can be much more efficiently in the shop floor. Because when I've talked about the preparing the process, when we are going then to the machine tool, somehow the operator in front of the machine, the person have to bring the tools to the machine, for example, the specific tools which will be needed. And we have a new app, it's called Toolmaster, for example, and thereby it's a really good end-to-end solution because this app is connected to every kind of step during this process.
You want them to bring the right tools at the right time.
These tools will be measured, and what kind of diameter, what kind of length has this tool. They will be measured, and automatically the data go to the machine tool. The machine tool will exactly know exact diameter. So that's one thing. The operator is really assisted to bring in the tools, and in the end the machines directly knows, this is the kind of tool which I have now with that kind of data, and this data is also available in the programming phase. So that's somehow an example.
But I still want to know about the general size of the improvement. Like if you do this right, is the efficiency of the production going up by 1%?
80%
How much?
faster, 80% faster tool loading.
80%?
Process. Yes, it's really...
So it's not a minor adjustment, like you're really changing.
Really, because you have to think about the machines, they are really good at the moment. They are precise, they can manufacture really good things. But these machines have to be programmed. These machines have to be prepared.
We humans have to do all those. Okay, so we are the inefficient, but the machine is efficient already.
Yeah, so all the processes around the machine are really manual, and there is a really good opportunity to improve. And like I've said it before, this tool example, 80% faster tool loading processes in the shop floor for the operator. And of course, that means that the machine tool is running more and more. We have to increase, we call it spindle hours. So
it's just like with an airline, yes? You don't want the planes on the ground, you want them flying. You want your machine to be drilling and making parts instead of sitting there waiting for somebody.
Yes, and such data-based or software-based solutions can be very helpful to increase this kind of spindle hours or productivity of the machine. That's really important.
So I know why you're so passionate about it, but what's next for you? Like, where does your career take you with it as the technology is changing and advancing?
I really like what we have seen now in the automotive industry. Yeah, please think about it. My first car, really no digital solutions were there. Yeah, a lot of things can be done by yourself. Yeah, changing parts in the car.
Yeah,
And
done
things
it more
like
than
that.
once.
And now when
Not
you're
on my new car.
yes, and now when you're stepping into a new car, it's like how to say it, a computer itself. Yeah, a lot of cool things, a lot of sensors are there. The car is connected with your smartphone directly.
Yeah.
And we have that kind of stages for autonomous driving. These 5 stages. And I think when you're asking for the future, think about how these 5 stages in regards to autonomous
Oh, so
manufacturing.
you think about same sort of concept. Like, so which stage are you right now on
I
are you
think-
stage 2? Are you stage 3 by now?
More or less something like that. Yeah, because we have already sensors integrated in the machine tools. We are also at the moment using first database models, but the people in the shop floor are at the moment the center and have to be assisted. So it's assisted based manufacturing, yeah, or assistance for the people who are working in the shop. But in the future, of course, we can go more up into the direction of stage 4, for example, and even think about this kind of dark factories. Yeah,
When you're fully automated, you just provide designs and let the system.
It's not the solution for every case of company, of course, but there are companies and there are settings in which that makes sense. And there are already first factories which we have seen, which are such kind of dark factories. Yeah, and of course, it's important to build solutions for every kind of second, but it's a really cool thing to look into the future and then think about such autonomous.
Imagine of what's possible.
Yes. Yes.
Marcel, that's fascinating. Thank you. Thank you for an awesome conversation. It was a pleasure chatting with you.
Thank you very much. It was a pleasure to me as well.